Hello, this is Shushmita and welcome to the session 5 of units and measurements. Today we are going to learn about vernier calipers and screw gauge. We are going to solve problems involving those two. So let us get started. This is how the vernier scale looks like. It is used to measure the length, diameter, width of very small object like this small metal ball, or this is a metal string and we want to measure the diameter of it, or suppose this is a glass beaker and we want to measure the thickness of the glass, then we can use the vernier scale to measure this diameter or the thickness of the beaker or the diameter of the metal ball over here. So objects that are much smaller than the order of centimeter can be measured using a vernier scale. Now you see that this instrument is provided with two scales. One scale is along this and this is called the main scale. This can be either a centimeter scale or a millimeter scale. And another scale is provided here, a small scale which is called the vernier scale. It does not have any unit. It has smaller divisions than the main scale. So if my main scale is in millimeter and these are the markings for millimeter, then our vernier scale will have smaller markings to divide these gaps into much smaller gaps. In an ideal case, if our vernier does not have any error in it, in that case, if we remove this object from here and if we slide our vernier scale to this point, then the 0 of the main scale, as you can see over here, and the 0 of the vernier scale should coincide like this. Like this, you can see that the 0 of the vernier scale and the 0 of the main scale coincide. We will now learn how to measure the size of the object using a vernier scale. For that, we need to know about two quantities. One is the vernier scale division, main scale division, and then we'll also have to know about the least count of a vernier scale. So if our 0 coincides over here, we will look for the next mark on the vernier scale that coincides with one of the mark in the main scale. So let us check for it, and you see this mark over here, this 10th mark on the vernier scale coincides with this mark on the main scale. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The 20th mark on the vernier scale matches with this point on the main scale. Let us count the divisions in the main scale. So this is 5, this is 10, this is 15, 16, 17, 18, 19. So 19 division in the main scale, which is called 19 main scale division, is coinciding with 20 vernier scale division. That means one vernier scale division is equal to 19 over 20 main scale division. So the vernier count can be written as 1 main scale division minus 1 vernier scale division expressed in main scale division as 1 by 20th of the main scale division. So in the main scale division, let us consider this is a centimeter scale. In this scale, we could only measure 1 over 10th, that is 0.1 centimeter, but in the vernier scale we can measure 0.1 by 20 up to 0.1 by 20. which means 1 over 200 or half over 100 or 0.5 into 10 to the minus 2, 0.005. This small amount of value if we use the vernier scale attached with the main scale. Now we are going to learn about another quantity, and that is called the least count of the vernier scale. The least count is nothing but the vernier count multiplied by one main scale division. And if this is our centimeter scale, let us consider for the moment. So 1 main scale division is 1 over 10th centimeter. So if we multiply this by 0.1 centimeter divided by 20, then this is equal to our least count. How can we measure the size of the object using this? Look at this object. We will first look for the main scale reading. So the main scale reading is the point where the 0 of the vernier scale coincides with the marking on the main scale, and this is 1, 2, 3, 4, 5. So the main scale reading is 5, and if let us say this scale is in millimeter, so each of the marking is 1 millimeter, 2 millimeter, 3 millimeter, and so on. So our reading is 5 millimeter. Now we want to make our measurement more precise, so we will now look for the next line on the vernier scale that matches with one of the marking on the main scale. And for us, this marking is closely matching with the main scale marking. So this is the 10th marking on the vernier scale. So to get the final value, what we have to do is we have to take the number of markings in the vernier scale that matches with one of the marking in the main scale and multiply it with the least count. Let us consider for the moment that the least count of this instrument is 0.05 millimeter. So we have to multiply this 10 with 0.05 millimeter, and we will get our answer as 5 plus 0.5, that will become 5.5 millimeter. Let us solve a simple problem to understand it better. 1 millimeter marks are present on the main scale. Whenever you are reading a problem, try to write down as much data that is provided in your question so that you do not have to read the question all over again, and that will save you a lot of time. So here it says that 1 millimeter marks are present on the main scale. What it is trying to say that each mark is 1, 2, 3, 4. Each mark is 1 millimeter. That means our 1 main scale division is equal to 1 millimeter. The total number of divisions on the vernier scale are 20. So 20 vernier scale division matches with 16 main scale division. That means 1 vernier scale division is 16 over 20 main scale division. Calculate the least count of the vernier scale. We know that the least count is 1 main scale division minus 1 vernier scale division, or 1 minus 16 over 20, which becomes 4 over 20, or 1 by 5. Or the least count is 1 over 5 into 1 main scale division, which is 1 millimeter. So this is 0.2 millimeter. That is our least count for the vernier scale, which has these specifications. Now, if you remember, in our previous session of error calculation, I told you that a vernier scale can have an error that is called an offset error, which is a systematic error present in the system. Ideally, if a vernier scale has no error in it, then when we slide this vernier scale towards the main scale 0 should ideally coincide with the vernier scale 0. But in case it does not coincide with the vernier scale 0, like in this case, the 0 is offset to the left, or it can also be offset to the right. In that case, the vernier scale 0 will be somewhere like this. Then our actual reading and our measured reading will vary. I'll try to explain that with a very simple example. Let us consider this is our object and we are measuring the length of the object using a simple centimeter scale, which is like this. But unfortunately we do not have a provision to move the scale backward or forward. So our scale is fixed and we bring the object to this position, but the 0 of our scale starts from here. So this is 0, 1, 2, let us say this is 3. So our length comes out to be, if these are in centimeter, then our length comes out to be 3 centimeter. However, the object does not start from here, the object starts from here. So if our scale was correct, then the 0 would have started from here and we would have got the correct reading would have been 4 centimeter. So if the 0 is offset to the right, then we get a value which is lesser than the original value and we have to add this extra 1 centimeter, which is our error, to our original reading to get the correct reading. And this error is called the negative error because error is always subtracted from the system. I had told you earlier in our previous session on error management. So if this is our measured reading, we always subtract the error from it to get our correct result. But in this case we have to add this one to it. So instead we define this error as a negative error so that this minus and minus sign adds up and gives us the correct value. So this is our measured value 3. We are adding it with the negative error to get the correct value. Now consider another case in which the 0 of our scale starts from here, so it is offset to the left. In this case, our reading starts like this: 1, 2, 3, 4 and 5. So now we are getting the length of the object as 5 centimeter, but it is greater than the actual length of 4 centimeter. 4 centimeter is our actual length. Let us call this the actual length. And this is our measured length. This was the negative error when our vernier was offset to the right, and when our scale is offset to the left, we found an error. We found that our measured length is 1 centimeter greater than that of the actual value. So we have to subtract this 1 centimeter from our measured length to get the actual length. That means we can simply subtract the error. So we can call our error a positive error. Hope the concept of positive and negative error is clear to you, because the same concept holds in case of a screw gauge, and we will be asked to solve problems depending on this knowledge, when in the question they will not be giving us directly if our error is positive or negative, but they will give us some indirect statement like it is offset to the left or offset to the right, or in case of a screw gauge, offset above or offset below, and we have to find out the actual reading by subtracting the error from our measurement. Therefore, understanding the zero error is very basic and essential to solve problems involving screw gauge and vernier calipers. Let us dive right into our first problem. Zero error of a vernier is given to be +2. That means we are dealing with a positive error, and it is our positive error is of 2 vernier scale division. The least count is given, so the value of the error is 0.02 centimeter. They want to know about the zero correction too. So to correct the error is always subtracted from the system. So we have to subtract this error from the system, and this will become minus 0.02 centimeter. So to correct the value, we have to subtract 0.02 from the system. So this is the correct answer. Do not make a mistake here. Our error is positive, but the correction will be negative. If our error was a negative error, then the correction would have been, we would have to add that amount to our measured value to get the correct amount. Moving on to the second problem. In an experiment, angles are required to be measured using an instrument. In the instrument, 29 division of the main scale. As soon as you get an information, try to write it down. In that case, you can solve your problem faster. You will not have to read the problem again and again, and that will save you some time. So 29 division of the main scale coincide with the 30 division of the vernier scale. And the smallest division of the main scale, which is the main scale reading or main scale division, is 0.5 degree. It is given. Then the least count of the instrument is given. So we know that one vernier scale division is equal to 29 by 30 main scale division. The least count we can find out as 1 main scale division minus 1 vernier scale division multiplied by the 1 main scale division. So it becomes 1 over 29 by 30 into 0.5 or 1 over 30 into 0.5 degree. Now 1 degree consists of 60 minutes. So let us multiply this by 60 minutes and make it to 60 seconds. Divided by 30, which becomes 60 seconds. So our scale can measure up to 60 seconds or 1 minute. That is the least count. So let us look at our options here. This 1 minute is our answer. Once you start your physics lab in school, you'll get to see these instruments very frequently. This is another instrument that is used to measure length, diameter and size of objects that fall in the range much smaller than centimeter scale. In this you can see here is a circular scale, and the circular scale can be rotated like this. When you rotate that scale also advances in this direction. So if it is in this position right now, if you rotate this, it will advance and come to here, just like a screw. You have seen the screw that we used to, or the nails that we have in our home, and or like the cap of your bottle. If you keep on rotating it, it also goes inside the neck of your bottle and they sit together. Therefore, when you rotate this circular scale, it also advances in this direction, and the amount of length that it advances in one rotation is called the pitch. We have a scale attached here, and this is the linear scale that gives us the measurement of the pitch. That means how much length it advances with one rotation. So now the circular scale position is like this. The object that we want to measure, we have to put the object in between these two hands of our device. Then we will have to rotate this, and this will also advance in the forward direction till it coincides with the object perfectly and there are no gaps left in between these two hands. Then we will take the reading of our circular scale as well as our linear scale to measure the size of the object. I have zoomed out the circular scale. Over here you can see, so there is a 0. This line is considered as 0. this linear scale line is considered as 0. If we close this, if we bring this up to here, then it will look like this. So in an ideal case, the 0, you can see the 0 over here, there are markings on the circular scale as well to measure in degrees, and the 0 of the circular scale should ideally match with the 0 of the linear scale when there is no error in our instrument. But just like that, in case of a vernier scale, screw gauge can also have a 0 offset error, which is also a systematic error, and if we are able to estimate the amount of error, we can always remove the error from our measurement either by subtracting it to our measured value or by removing it or by adding it to our measured value. So if the 0 is before the 0 of the main scale 0, then our error will be positive. In the similar manner that happened in the vernier scale, and if our 0 falls after the 0 of the main scale, or above the 0 of the main scale, then our 0 error is negative, because our measured length will be less than the actual length of the object. Therefore, we have to add the error to our object. So we have to make the error negative so that we can add that value finally with our measured value. Here also, for the ease of our measurements, we define two quantities. One is the pitch of the screw gauge. As I already told you, pitch is how much distance it moves in one circular rotation of the circular scale, how much linear distance it moves forward, divided by the full number of rotation. Because the distance it moves in one circular rotation may be very small, and very so small that you will not be measure it up to the accuracy. So you will rotate the scale as much as required so that it becomes at least one of the reading or one reading in the circular scale. And to understand how many times we rotated the circular scale, what we can do is we can mark the 0 over here, or we can see which point on the circular scale coincides with the point of the, so this point you can see the 0 is over here, it does not coincide with our linear scale, so we can mark a point over here. Then we rotate the scale, and each and every time this point comes back to this location, that means one complete rotation, and we will have to do as many rotations as needed to make the circular scale advance to at least this position, because this too is one measurement in the linear scale. So we can equate this one measurement in the linear scale, if this is in millimeters say, divided by the number of rotation. Suppose we had to rotate the circular scale 5 times, then this will become our pitch. And how to measure the value, how to measure the size of the object that we have placed here is, for that we will have to find out the least count. So that is pitch divided by the total number of divisions in the circular scale. So our scale over here has a total of 50 division. This is starting from 0, 5, 10, 15 and moving on. This is 45, so this is 50. 50 and 0 is the same thing, so this is our total of 50 divisions. So this becomes number of pitch divided by 50, and that is our least count. Let us start with our first problem. Screw gauge gives the following reading when used to measure the diameter of a wire. The main scale reading is given to be 0.5 millimeter. The circular scale reading is 52 divisions. We have to multiply this with the least count to get our final reading, and the least count is given indirectly. It says that 1 millimeter on the main scale corresponds to 100 divisions on the circular scale. That means This circular scale has total 100 divisions, and if we rotate this scale once, then it advances in this direction to 1 millimeter. So that means the pitch is, the distance moved is 1 millimeter, that is corresponding to the one rotation. So our pitch is 1 millimeter, and the least count is the pitch divided by the total number of divisions on the circular scale, which is 100. So our least count is given indirectly, which is 1 millimeter over 100, or 0.01 millimeter. So this becomes 52 into 0.01 millimeter, or 0.52 millimeter. Let us surf through our options. They are given in centimeter. So if we convert this into centimeter, it becomes 0.052 centimeter, or this option is correct. The next one is also a very simple problem. Here they have already given the least count as 0.01 millimeter. Main scale reading is 2 millimeter, and the circular scale reading is 40. Determine the total reading. We have to multiply the circular scale reading with the least count, which is 0.01 millimeter. So this becomes 0.4 millimeter. Our total reading becomes 2.4 millimeter. But remember that this is given up to the accuracy of 0.01 millimeter. So we have to write our answer up to 2 digits after the decimal. So 2.40 is the accurate answer. A student measures the length of a rod as 3.50 centimeter. That means he measures it up to the accuracy of 2 decimal places. After the point 2 decimal places, 0.01 centimeter is the precision of his measurement. So our instrument should have that kind of preciseness. So meter scale is not an option. Screw gauge having 100 division and a pitch of 1 millimeter is 1 millimeter divided by 100. So the least count is equal to 0.01 millimeter. That is a very fine accuracy than this. So this is also not an option. The second option is similar to this, except for it has 50 divisions. So this becomes, which becomes 0.02 millimeter. This precision is much finer than this. So this is also not our option. The only option we're left with is option D. Let us check for the correctness of the option. 10 division in the vernier scale matches with 9 division on the main scale. So least count is 1 main scale division minus 1 vernier scale division, 1 minus 9 over 10, or 1 over 10 main scale division. And our main scale have 10 division in 1 centimeter. So 1 main scale division is 1 over 10 centimeter. So the least count becomes 1 over 10 into 10, or 0.01 centimeter. This is the same precision as that of our measurement. So this is the correct answer. A screw gauge, there are 50 division on the thimble scale. The screw advances 1 millimeter in one complete rotation of the screw cap. That means our pitch is 1 millimeter. In another screw gauge, there are 100 division and the screw advances 1 millimeter in one complete rotation of the screw cap. So here also the pitch is 1 millimeter. But the least count changes. The pitch divided by, in the first case this is 50 divisions, and in the second case this is 1 millimeter divided by, you can see, 100 divisions. So our least count is 0.02 millimeter, and here our least count is 0.01 millimeter. 0.01 is less than 0.02. So our second screw gauge is providing more accurate measurements. In this problem they have given us details about one vernier scale and one screw gauge. The one main scale division of the vernier scale is given. They are saying 1 centimeter on the main scale is divided into 8 equal divisions. That means this is the main scale division. The scale is like this: 0, 1, 2, 3, 4, 5, 6. This is 1 centimeter. So each of these lines can measure up to 1/8 of a centimeter. The next information that is given is that 5 divisions in the vernier scale coincides with the 4 division in the main scale. That means one vernier scale division is 4 by 5 into the main scale division, or the least count is 1 minus 4 over 5 or 1 over 5 main scale division, which is 1 over 5 into 1 over 8 centimeter or 1 by 40 centimeter. What are the informations given about the screw gauge? There are total 100 divisions on the circular scale, and one complete rotation of the circular scale moves it by 2 division on the linear scale. So if we move it twice, it will move. If we move it once, then it will move 2 divisions on the linear scale. Let us consider 1 division on the linear scale is equal to x. Then 2 division is equal to 2x, and our pitch is 2 divisions divided by 1 circular rotation. And the least count of the screw gauge is therefore pitch divided by total number of divisions, which is 100. This is the least count of the screw gauge. Let us write it down over somewhere here, like here. And the least count of the vernier scale is 1 over 40 centimeter. They want us to find out which of the instruments is used in, which of these 4 options are correct. Option 1 is pitch of the screw gauge. The pitch of the screw gauge is 2x. That is twice the least count of the vernier calipers. Twice the least count of the vernier calipers. Then the least count of the screw gauge is 0.01 millimeter. Is it true? The least count of the screw gauge is 2x over 100. 2x is 2 over 40 into 100 centimeter. That is 0.05 over 100 centimeter, or 0.0005 centimeter. Multiplied with 10, this becomes 0.005 millimeter. So option 1 is incorrect. Going on to the second option, if the screw gauge pitch of the screw gauge is twice that of the least count, so the same condition, then the least count of the screw gauge is 0.005 millimeter, which is true. So this option is true. The pitch of a screw gauge is given 1 millimeter, and there are 100 divisions on the circular scale. That means our least count is 1 millimeter divided by 100. A student measures the diameter of a wire using the screw gauge, and he gets the mean scale reading. So the mean scale reading is 5 and the circular division is 25. We have to multiply this with the least count to get our final reading, which is 25 into 1 over 100. And this will come in millimeter, of course. So 5 plus 0.25 millimeter, or 5.25 millimeter. Now if the screw gauge has a positive zero error, so our error is of the order of 0.03, but error is always subtracted. So if this is positive, this sign will also come as negative. Then the correct value of the diameter will be 2 So 5.22 millimeter. And this is one type of question that is asked in the IIT JEE and NEET examination. This is a very interesting problem. Look at this problem. Pitch is given. So they have already given you the pitch. They have also given you the least count. Because our circular scale have 50 division. Sorry, this is 0.5 millimeter. So our least count is pitch divided by total number of divisions, which is 50. So this comes out to be 1 over 100 or 0.01 millimeter. The two jaws are brought in contact and the 45 division. So if you remember, a circular scale has marking like this, then the rest will fall on the other side. 50 and 0 is the same because our scale has a total of 50 divisions. So this is the ideal case, but in our case they are saying that the 45th marking coincides with the linear scale. That means our 0 is somewhere over here, then this is 10, 20 on the other side, 30 and 45. So our 0 is offset ahead of our main scale, our linear scale you can say. What kind of error was that? In this kind of error, the value that we are taking is lesser than the original value. So this is a negative error. If you remember, I taught you in the previous slides. Let me show you here. If our 0 is ahead of our linear scale 0, then this error is a negative error because we are taking a measurement that is lesser than our original value, and we have to add this error to our measured value to get the original value. So in our question, we have to add this much. This is 50. So 50 minus 45. 50 minus 45, because 0 and 45, 0 and 50 is the same thing. So 5 circular scale division, and that corresponds to 5 into the least count, which is 0.01 millimeter or 0.05 millimeter. This is our error, and our error is a negative error. Now let us look at what is given. So our main scale reading is 0.5. 25th division coincides with the main scale line. That means this multiplied by the least count. This is our measurement, 0.25, which is 0.75, and this is our error. This error has to be subtracted, which in turn adds up and becomes 0.80 millimeter. This is one important type of question. In this kind of problem, do not make a mistake in understanding if your error is positive or negative, because if by mistake you did a wrong assessment of your error, suppose in this case you consider this error as positive, then your answer will come out as 0.75 minus 0.05, which is 0.70, and this is also given in the option, you see. So your answer will be wrong. So the building up the theoretical concept is very much important. Then only you can solve the numericals correctly. Mugging off will not do. That is all about today. In our next session, we are going to solve the problems I had given you as homeworks. In this session also, I have given you some homeworks. Try to solve them first by yourself at home. See you in the next session. Till then, take care. Bye bye.